So in this lesson, we will learn how to solve equations using iterations. It doesn't need to be quadratic. It can be cubic as well. It can be more than power 2 as well. So when the equations are complex, more than 2 power more than power 2, we don't know how to find the solutions. But there is a method called iterations. Iterations mean do something continuously until you get to somewhere. So we will see how we can use iteration to find for a complex equations. So here the equation is x to the power 3. Not, this is not a quadratic equation. This is cube power 3. So x cube plus 5x is equal to 20. So here we will use, if you put x is equal to 0, you will be getting 2. That means x0 is equal to 2. And they ask you to find the answer in 3 decimal places. So what you have to do is you have to rearrange the formula as x is equal to something. That is the first part you have to do. So here, I mean, x can be on the right hand side as well, but you have to write it equal to as x is equal to something. So you can rewrite this one as x cube is equal to 20 minus 5x. Then you can write x as 3 cube of 20 minus 5x. So here you have to write xn plus 1 is equal to 3 square root of 20 minus 5xn. So the first part we are going to have xn plus. The next x is related to the previous x, xn. The xn, using that xn, you are going to find the xn plus 1. So n can be any values. So but we found that one x0 is equal to 2. So xn, for n is equal to 0, you will be getting x1 with this formula. So we will be getting x1 is equal to 3 cube root 20 minus 5 into 2. x0 is equal to 2. Therefore, you will be getting 3 cube root of 10, that is equal to 2.154. You can use the calculator to find this one. So now we know that one x1 is equal to 2.154. Now we can find x2 using x1, isn't it? So we found x1 using x0. So we can find x2 using x1. If you apply the same thing in the formula, we'll be getting 2.097. So by using x2, we can find x3, applying that formula. So we'll be getting 2.118. Similarly, we can find x4 using x3, x5 using x4, and so on. So here x6 and x7 is going to have a similar value, 3 decimal place, they are equal. So we have to say that one x squared plus 5x is equal to 3. 2.113 is the answer for 3 decimal places. Okay. If you want to use calculator, you can use it, but you have to use the ANS function to remember the previous value, and you can substitute to calculate this one. So we will look at another example. Here the equation is x to the power 3 plus 2x is equal to 7. So we can rewrite this one as xn plus 1. We have to bring the x to the one side, and that one is going to be n plus 1. The x on the right hand is going to be n. So xn plus 1 is equal to 3 cube root of 7 minus 2xn. But if x is equal to 1, if you put x is equal to 1 in the formula, then you will be getting 3. But if you put x is equal to 2 in that formula, you will be getting 12. Yeah. So the left hand side is 3 and 12. But those are less or higher than 7. If you put 1, then the left hand side is 3. That is much less than 7. If you put 2, then the 12 is much higher than 7. Therefore, we know that what x has to take the value between 1 and 12. So how do you do this one with iteration? So they are saying initial value they will be giving us. So the x0 is equal to 1, and substituting the iteratively, then we have to find it. So if they are saying x0 is equal to 1, if we know x0 is equal to 1, then we can find x1 by placing x0 to 1. Then we can write x1 is equal to 3 cube root under 7 minus 2 into 1. So that one you will be getting 1.710. So using x1 you can find x2, using x2 you can find x3, and so on. So here the x7 is equal to 1.569. The x6 and x7 are equal. Then it's no point going forward. Whenever you get the equal value, then you can stop that one. So there, so x7 is getting to that place. Therefore, so the x cube plus 2x plus 7 is 1.69 is the x value it will take. That is the approximate. It's not the perfect one, but to the 3 decimal place, when x is equal to 1.569, that will satisfy the equation.